Students, now I am teaching intermediate first year, first chapter functions. Okay, problem number 2. Which of the following are injection or subjection or bijection? Injection means the distinct elements of A is mapping with distinct images of B. Okay, subjection means the are mapped by the elements of at least one element of A. Okay, so bijection means the function it is injection and bijection, or the function which is injection and subjection, then the function is bijection. Okay, so here let us take how we can prove that injection means. Okay, if two elements, we take any two elements in the set A, if their images are equal, then elements is also equal. Okay, so let us take x1, x2 it belongs to A. Here real numbers is domain, codomain is also real. Domain is real numbers, codomain is also real numbers. Okay, x1, x2 is belongs to domain, and f of x1 is equal f of x2. If you get x1 is x2, then the function is injection function. So f of x1 means in the place of x you can put x1. Okay, so that is 2x1 plus 1 by 3 is equal to x2 plus 1 by 3. Here 3 divide. Okay, so 2x1 plus 1 is equal to x2 plus 1 by 3 into 3. 3 cancel. 2x1 plus 1 is equal to x2 plus 1. So 2x1 is equal to x2 plus 1 minus 1. Plus 1 minus 1 cancel. 2x1 is equal to x2. So that is x1 2x2 by 2. 2 cancel. x1 is equal to x2. Okay, the images are equal. The images are equal. Then elements is also equal. Okay, ma. So therefore it is a f of x, the function f of x 2x plus 1 by 3 is a injection function. Okay, next prove that it is a subjection function. Okay, subjection function how you can prove? Let us take f of x is equal to y. Okay, so let y belongs to R and f of x is equal to y. So what is f of x? 2x plus 1. 2x plus 1 by 3 is equal to y. So 2x plus 1 is equal to 3y. 2x is equal to 3y minus 1. X is equal to 3y minus 1 by 2. Here y belongs to R means what? Y is the belongs to codomain. Here the codomain is what? Real numbers. Okay, so here let y belongs to R. There exists an element 3y minus 1 by 2 is belongs to R. If R is belongs to codomain, the element 3y minus 1 by 2, that means this number is in the form of y term. Okay, it also belongs to codomain. Okay, such that f of 3y minus 1 by 2 is equal. So here f of 3y minus 1 by 2. So we can substitute in the place of x 3y minus 1 by 2. We can get as y. So that is here 2 into 3y minus 1 by 2 plus 1 by 3. Okay, so 2 cancel. 3y minus 1 plus 1 by 3. Minus 1 plus 1 cancel. 3y by 3. 3 cancel. That is equal to y. So f of 3y minus 1 by 2 is equal to how much more? Y. So therefore f from R to R, the function is defined f of x is equal to x plus 1 by 3 is a subjection function. So therefore it is a bijection function. Why it is one? It is an injection function and it is a subjection function. Therefore it is a bijection function. F from R to 0 to infinity. Okay, positive real numbers. Okay, so for this one you can put as R plus positive real numbers. Okay, the codomain is positive real numbers. Domain is real numbers. Okay, so defined by f of x is equal to 2 for x. Okay, so same how you can prove it is injection function? Let us take x1, x2 is belongs to R Okay, so and f of x1 is equal f of x2. So that is 2 power x1 is equal to 2 power x2. Bases are equal, powers also equal. In NHS base is 2, in RHS base is 2. The bases are equal, powers are also equal. So x1 is equal to x2. So therefore f of x is equal to 2 power x is a injection function. Is a injection function. Okay, next prove that it is a surjection function. So let us take y belongs to 0 to infinity, 0 to infinity, and f of x is equal to y. F of x is equal to y. So what is f of x? 2 power x. 2 power x is equal to y. Okay, this exponent form we can write in logarithm form. Okay, how we can write logarithm form? X is equal log y base 2. X is equal log y base 2. Okay, now here it is in the form of a power x is equal to n. We can write as x is equal log n base a. Okay, now, so here let y belongs to 0 to infinity. There exists an element log y base 2 is also belongs to 0 to infinity such that f of x is equal to y command we want to prove. So that is f of log y base 2 is equal to 2 power. So what is the f of x? 2 power x kadma f of x entama 2 power x kada. So 2 power log y base 2. 2 power log y base 2. In the place of x, you can put as log y base 2. Okay, we want to prove f of x is equal to y. Okay, so here, which formula you can use here? A power log n base a. We can write as n to the power of log a base a. Okay, so that formula you can apply here. That is y to the power of log 2 base 2. So log 2 base value is 1. So therefore, f of log y base 2 is equal to y. So therefore, f of x is equal to y. So therefore, f of x is equal to 2 power x is a surjection function. So therefore, it is a f of x is equal to 2 power x. It is a bisection function. It is a bisection function. You know, right? Next one. F from 0 to infinity, the domain is 0 to infinity. That means the positive. Okay, positive real numbers. 2 are codomain. Okay, real numbers. Defined by f of x is equal to log x base e. Okay, so here, okay, given f of x is equal to log x base e. So let x1 comma x2 comma is belongs to positive real numbers. Okay, such that f of x1 is equal to f of x2. Then prove that x1 is equal to x2. Then the function is injection function. So log x1 base e is equal to log x2 base e. Here we know that logarithms of any two number, their base is same, then the numbers are also equal. Okay, so that is x1 is equal to x2. x1 is equal to x2. So therefore, f of x is equal to log x base e. E is the what? Exponential constant. Okay, so log x base e is an injection function. Next, prove that f of x log x base e is a surjection function. Let y is belongs to r. Okay, or such that f of x is equal to y. So that is log x base e is equal to y. This logarithm form we can write as exponent form. X is equal to a power y. X is equal to a power y. Okay, so here let y belongs to r. There exists an element e power y is belongs to r such that f of x is equal to log x base e gamma. Here f of e power y is equal log e power y base e. In the place of x, you can put e power y. Okay, so here which formula you can use? Log x power n base a is equal n log x base a. So same formula you can apply here. Then y into log e base e. Log of any number base of the same, its value is 1. So that is y into 1. That is equal 1. F of log y, okay, f of e power y is equal 1. So therefore f of x is equal log x base e is a surjection function. Okay, so therefore f of x is equal log x base e is a bisection function. Therefore hence proved. F from 0 closed interval 0 to infinity to closed interval 0 to infinity. So positive real numbers, positive real numbers. Okay, that means 0 equal greater than 0. Equal to 0 greater than 0 is defined by f of x is equal x square. Okay, same now. So let x1, x2 belongs to positive real numbers such that f of x1 is equal f of x2. So that is x1 square is equal x2 square. Powers are equal, base also equal. So x1 is equal x2. x1 is equal x2. So therefore f of x is equal x square is an injection function. Is an injection function. Okay, so next one. Let y belongs to R and f of x is equal to y. So f of x is how much? X square is equal to y. X is equal square root y. So that is plus or minus. That is plus or minus root y. Okay, so here let y belongs to R. Positive real numbers come. Okay, so there exists an element plus or minus root y is belongs to R. Okay, such that f of x is equal to x square. So f of plus or minus root y plus or minus root y whole square. So that is plus or minus square root cancel y. So plus or minus y. Plus or minus y. But here plus y is belongs to positive real numbers, minus y does not belong to positive real numbers. Okay, no? Obvious. Plus or minus y root y whole square, no? So that is here we can get as root y whole square, square cancel y. Okay, so therefore f of x is equal x square is a surjection function. So therefore f of x is equal x square is a bisection function. Fine. Next one. F from R to real numbers to positive real numbers defined by f of x is equal x square. Okay, so here let us take x is equal 1. X is equal 1. Okay, then f of 1 is equal 1 square is equal 1. Okay, next x is equal minus 1. Why? X is a what, ma? Real numbers domain. Okay, so then what you can get? F of minus 1 is equal minus 1 whole square is equal 1. Okay, so here for these two elements having the same image element. Okay, 1 and minus 1 having the same image elements. Okay, it is an injection function? No. Why? Because what is called integer function? The set of elements of A, the distinct elements of A having distinct images of in B. But here the two elements are in the same image, so therefore here 1 and minus 1 have same image is 1. So therefore f of x is equal to x square is not an injection function. Not an injection function. Okay, next let y belongs to R. Y belongs to R. Okay, so then consider f of x is equal to x square. Okay, f of x is equal to y, x square is equal to y, x is equal plus or minus root y. X is equal plus or minus root y. Okay, so here if y is equal to 1, so then x we can get as plus or minus 1, that is equal to x plus 1 minus 1. X we can get plus 1 minus 1. So the plus 1 and minus 1 both are in real numbers. Both are in real numbers. Okay, so here let y belongs to R plus, so there exists an element. There exists an element root y plus or minus root y is belongs to does not belongs to R plus na. Why? Because plus root y is belongs to, but minus root y does not belongs to. Okay, so therefore f of x is equal to x square is not a subjection function. Is not a subjection function. Therefore f of x is equal to x square is not a bisection function. Third is g is equal, the function g is 1 1, that means 1 mapping is 1, 2 is mapping 3, 3 is mapping 5, 4 is mapping 5, 7. A function from A 1 2 3 4, B 1 3 5 7. Okay, so here it is the A, it is the B. Okay, the function g is a mapping. The function g is a mapping. Okay, so here 1 2 3 4. Here 1 3 5 7. So 1 1 2 3 3 5 4 7 is a mapping. Okay, so g is a function 1 1 2 3 3 5 4 7. Okay, na? So here they given that g is a function 1 1 2 3 3 5 4 7 is a function from A to B. Okay, na? So if this is given by the formula g of x is equal to ax plus b, g of x, that means we can put the domain, we can get as range. Okay, so then find A and B. Find A and B. Okay, so given g is 1 1 2 3 3 5 4 7. Okay, so what the given formula? G of x is equal to ax plus b. Okay, so one is mapping with the element 1, 2 is mapping the element 3, 3 is mapping the element 5, 4 is mapping the element 7. So here put g of 1. G of 1 substitution g of 1 map they given that g of 1. Okay, 1 is mapping with the function g. E is how much more? 1. So g of 1 is 1. Okay, so here in the place of x you can put, we can get as a into 1 plus b is equal to 1. That is a plus b is equal to 1. It is the equation 1. Okay, next 2 is mapping the element 3. 2 is mapping the element 3. Okay, so that is g of 2 is equal to 3. G of 2. 2 is mapping element with the function g is how much more? 3. Okay, so that is in the place of x you can put 2. That is a into 2 plus b is equal to 3. That is 2a plus b is equal to 3. Okay, ma? Okay, ma? So it is the equation 2. What asking that? Find A and B. Okay. So two order pairs, these two order pairs 1 1 2 3, we can get the equations A plus B is equal to 1, 2A plus B is equal to 3. Okay, first of all you take that 3A plus B is equal to 5, 4A plus B is equal to 7. Okay, so the x value is okay, the mapping elements is 5 7. Okay, so from 1 and 2, from 1 and 2 equation, A plus B is equal to 1, 2A plus B is equal to 3. Here we can eliminate B, okay, by using subtraction, by doing subtraction equations. So when you subtract, the signs are changes. Plus B minus B cancel. Plus A minus 2A minus A, 1 minus 3 minus 2. So that is A is equal to minus A is equal to minus 2, minus A is equal to divide, minus minus cancel. A is equal to how much? 2. Okay, so the A value you can substitute. A value substitute in A plus B is equal to 1. That is 2 plus B is equal to 1. B is equal to 1 minus 2. B is equal to minus 1. So therefore A is equal to the values of A and B. A is equal to B is equal to minus 1. Okay, now